Have you ever wanted to create your own database based on IMDb, an online movie catalogue website? By the end of this video, we'll have a functional SQL database based on the IMDb website. Here is the homepage of imdb.com. There's a lot going on, links to trailers, cast members, and movies. Let's start with something simple but pretty core to a movie catalogue database, and that would be a movie. I'll click on this movie here, The Batman. We can see the page for this movie. We've got the title here, and under it is the number 2022, which I assume is the release year. There's a rating and what I think is the runtime. On the right, we have some information about ratings and popularity. Let's start creating our SQL database for this. I'm using an editor called DataGrip, and I'll work on a Postgres database, but you can use whatever SQL editor and database you like. I'll start by creating a new schema, which will be my area to contain the tables for the movie catalogue. To do this, right-click on the Postgres database, then select New, then Schema. The process in your SQL editor and database may be different. I'll name the new schema Movie Catalogue, then I'll click OK. The schema is created and is set to the active schema in my editor. I'm now ready to write some SQL. Let's create the first table. I'll start with a table for the movies. We saw an example on IMDb before. What do we want to store? On the movie page, we saw a title, which was The Batman. A movie title is a text value, so we'll add that to our table. I'll call this movie_title and give it the data type of text. This is a Postgres data type and maps to an equivalent of varchar in other databases. I don't need to specify the length in Postgres, but if you're using other databases, you may need to. How long should this field be? I would go with maybe 200 characters for now, but as you're populating data, you can increase it if you find a movie that doesn't fit. Now we should add a primary key so we can identify the record and link it to other tables if we need to. We can add a primary key here. I'll call it Movie ID and give it the type of serial, which is a Postgres-specific type for an auto-incrementing integer. Other databases have similar data types and features. You don't have to use an integer. I've created a video recently that compares the UUID data types to an integer data type for a primary key, which you can watch here or in the description. Now that our primary key is added, what else can we add? We have a number which is the release year, the rating, and the runtime. The release year seems to be a number, so we can add it as an integer. The rating is a text value. We have other values on the right of the screen that mention rating, so we should be a bit more specific with our column name for these. The runtime is in hours and minutes. Let's add these to our table. First, the release year. We can call this column release year and use a type of int. Then we have the rating. For our movie, it was PG-13. We could call this column something like parental rating or audience rating or classification. Let's go with classification. In Postgres, I'll use text again, but for other databases, you'll need a length. I think most classification values are pretty short, so maybe a length of 8 or 10 would be enough. Next, we have the runtime. On the page, it shows 2 hours 56 minutes. Now, we could look at this and say it has numbers and text values and a space, so we should store it as a text value. However, if we store it as text, it would be hard to work with. It would be hard to filter on movies that are longer or shorter than a certain runtime, or to show it in different formats. In this situation, we can see the runtime shown in hours and minutes, but we can actually store the value in some other format. So I would suggest storing this as the runtime in minutes, which can be an integer, and we can convert it to hours and minutes on a web page. I'll add this to the table and call it runtime mins, so anyone looking at the table knows what unit of measurement it is in. Those are all the columns we need for now. But we need to add our primary key constraint. You could add the words primary key next to the movie ID column, but I prefer to add it at the end here, so we can give it a better name. Our table is now ready. We can run this command and the table is created. I've created a project guide for the project in this video, which you can find in the link in the description. You'll get the full SQL to create the database, populate it with more data, a database diagram, and many more sample SQL queries. Alright, our table is created. Let's add some data to it. We can do this with an insert statement. We start with insert into, then specify all of the column names. Then we add the values clause. For the movie ID, I'll use the number 1. In DataGrip, there's a feature that shows the column name next to the value here, which I think is handy. In other editors, you might see this, or you might just see the value of 1. Next, we have the movie title. I'll type the Batman inside single quotes, and we need the single quotes to specify text values. I can then add 2022 for the release year, PG-13 for classification, and then we have the runtime. 2 hours and 56 minutes is equal to 176 minutes, so I'll enter 176. Our statement is now ready, so let's run it. In DataGrip, I can click Run and then choose the statement to run. In other editors, you may need to highlight the statement first, or click a different Run button on your toolbar. The statement is successful. Let's see what the data looks like. We can write a select statement to view the data. I'll just select all columns like this and then run the statement. We can see the results here. It shows the data we inserted, which is the data on the IMDb page for the movie. So far so good. What about this runtime minutes value? How do we convert that to show in hours and minutes like on the web page? Well, we could leave it up to the application code to do this, or we can do this using SQL. We'll use a couple of functions for this, and the specifics will depend on which database you're using. We first need to calculate the number of hours. We do this by dividing the number of minutes by 60. Let's add a new column for our calculations. We'll divide the runtime minutes by 60, then just run our statement. We see a new column here which has the value of 2. Now, there are a couple of things to realise here. If you are using a different database or editor, you may see a value of 2.93 here. This is because some editors round the value and some don't. I think it's better to be explicit, which means adding more detail so we specify exactly what we want. I'll do that in a moment. The second thing is the column header. In DataGrip, it shows as column inside question marks. We can add a better column name in our query. Let's make these changes. To show a column name, we'll add a column alias using the as keyword. I'll call the column runtime. Now let's tackle that rounding issue. For this column, we want to see the number of hours and we want to round down. So our value of 2.93 should be translated to 2. We can do this using the floor function in SQL. So we surround our calculation with the floor function, with the calculation as the parameter. If you're using a different database, you may need a second parameter for the number of digits. We can run this and we see the results here, which show our new column name and the updated value of 2. How do we calculate the minutes? The value we want to show is 56, which is the number of minutes left over after we add the 2 hours. How can we express this as a piece of code? Well, we can get our runtime minutes value, then subtract the number of hours multiplied by 60. So for 2 hours, we multiply the hours by 60 to get 120, then subtract this from 176. Another way we can do this in SQL is using a concept called modulo division, which essentially means perform a division and give me the leftovers. We can use this modulo division to get our value of 56. To do this, we use the mod function. This may vary slightly between databases, so look up how it works for your database. The first mod parameter is our runtime mins column, which has the value of 176. The second parameter is 60 because we want to divide this by 60 and see what's left over. That's all we need. I'll give it a column alias of leftover mins and have also updated the previous column alias. Let's run this. We do this and we see a new column with a value of 56. Success! Now we just need to combine these two values into one, then put in the letters of H and M, and we'll get the same output as the website. To combine these, we can copy and paste each of the functions to a new column. We use the double pipe character to concatenate it to a text value, which is the letter H then a space. Then we concatenate the second function which calculates the minutes, then add the letter M after it. I'll give it a column alias of runtime. We can now run this query. In the output, we can see our new column of runtime, which combines the hours and minutes into the exact value we need to see on our web page. So that's how we can store a value as an integer and show it as something else. Later in the video or in this project, we may need to sort or filter based on runtime, and having it in minutes will be much easier. Let's go back to the movie page and see what else we can add. What else do we have here? We have a picture here of the movie, which I think is called a movie poster. It's what you see on billboards or ads or signs in the movie theatres. We also have a video playing next to it, which could be the trailer. We've got the rating and popularity information on the right, which I'll come back to. Let's add the poster and trailer to our database. Our movie table is already created though. How can we add to it? We use the alter table statement. We will alter the movie table to add a column called poster. We could store the actual image file or video file in our database column, but I recommend storing these files on a server and then storing a link to the file within the database column. So we'll do that. We add the poster field as a text field and the same for the trailer. We can run both of these statements and the columns are added. The syntax for the alter table statement may be different in your database, and of course the data types may be different, so you may need to adjust them. We have two more columns now. Let's update these for our Batman row. For the poster value, we'll enter a fictional file path to an image file. In a real system, we would have a function that would allow an upload of a file which would add the image file to the server and then populate the file name into this field. So we can pretend that the file name is image145.jpg and it's uploaded to a folder called media. The same can be said for the trailer MP4 file. We run this and our data is updated. Let's see the data. We can use the same select query as earlier. This time we can remove those two columns that we used to calculate the hours and minutes, as we already have the combined value. We can add the columns for the poster and trailer here. Let's run the query. We can see our new columns here. If the application runs this query, it would then have more code to read these file names and load the files onto the page. So far so good. Let's see what else we can add. At the top of the page on the right we have some fields about ratings. We have an IMDb rating, which for this movie is 7.8 out of 10. It has a number of 836K below it. What does this mean? We can click on the rating and see a page for the ratings, which shows a few things, including the number of ratings submitted for each value from 1 to 10. So it seems like this 836K is the number of submitted ratings for this movie. What else can we see? The next field is called Your Rating, and if we click on that, we can provide a rating from 1 star to 10 stars. So we could assume that this is an input to the IMDb overall rating. Next to this we have the popularity. I assume this is some kind of algorithm to determine which movies are getting a lot of focus now. I'm not sure how this would be calculated. Let's add this rating concept to our database. We need a way to capture a rating submitted for a movie. We can do this by creating a new table, which I'll call rating. In this table, we have a primary key of rating ID. We have the movie ID, which stores the movie the rating relates to. We also have a rating value, which is the number from 1 to 10. We don't have a user ID to capture the user who left the review, but we could add that later. Now we can add a few constraints. We'll add the primary key constraint. Then we add the foreign key constraint to the movie table. Now, one thing that can help us is to limit the rating values to between 1 and 10. An integer value could store values in the hundreds or thousands or even higher, but it would improve our data quality if we limit it to between 1 and 10. So we can do this with a check constraint, which I've added here. Our table is now ready. We can run this and the table is created. Let's populate this table. Now, I won't add 836,000 rows into this table, but I can add a few rows so we get a rating of around 7.8. We can run these insert statements and the rows are inserted. How can we calculate the average rating? The website said it had a weighting applied. We could use a complex formula here, but for our purposes we can just use a simple average. Let's write a query to find the IMDb rating for a movie. We can select the average of the rating value field for a specific movie. We only have rows for one movie, but this is the query we would use to do it. We can run this and see the average here. It shows a value of 7.875. On the website it was rounded to 1 decimal place, and we have 3. If we also wanted to round to 1 decimal place, we could. We can use the round function to round it to 1 place. We add this function and run the query. We can see the rating value with 1 decimal place. What do we do with this value? How do we get it to show on the movie page? There are 2 ways that I can think of. We could store this value on the movie table as a new column and just select it when we show the movie page. However, this would mean we need to update this whenever we insert, update or delete a row in the rating table. Another approach would be to select this average value each time we want to see a movie page. It would mean we don't need to keep another value updated, but it means running this average each time. Either way can work, it just depends on what you want to do. For our example, we won't store this in the movie table. We'll run the average each time. So we can update our movie query to also select this average value. We've added the average function that we used before and joined to the rating table. To make our query easier to work with, I've added table aliases of M for movie and R for rating. Because we have the average function, which is an aggregate function, we need to add a group by. We group by all of the other fields. Then we can run our query. We see our result here, which has 1 row for our movie and a new column for the IMDb rating. Instead of grouping the data like this, we could have put the average function in the select clause and done a correlated subquery, or we could have written the average function as a window function. Or we could have used a subquery in the from clause. There are several ways to make this better. I've listed the SQL code for each of these methods in my project guide for the project in this video, which you can find in the link in the description. You'll get the full SQL to create the database, populate it with more data, a database diagram, and many more sample SQL queries. After the movie poster and trailer is a series of words here: action epic, epic, superhero, drama, and so on. These look like keywords or genres. If I hover over one of them, I can see the word interest in the URL. What happens if we click one? We are taken to a new page that has a photo, a title of the thing we clicked on, and a link back to all interests. So it seems like this is called an interest, and a movie has many interests attached to it. How can we add this to our table? We could add a new column into the movie table called interests, and then put all of these terms into the column. However, on the IMDb site, each of these interests has its own page, which indicates they are an entity separate from the movie. So we should create a separate table for them. It also allows us to easily maintain the relationship between interests and movies. Let's do this. First, we create a new table called interest. I'll give it an ID for the primary key and an interest name. We run this and the table is created. Now let's add some data to it. I'll add this insert statement which inserts some rows into the table. We can run this and the data is inserted. Let's select from the table. We can see the different interest values here. Now this is just the list of possible interest values. We need to relate these to our movie. How do we do this in our database? How does an interest relate to a movie? We've seen that a movie can have many interests, and on the interest page, an interest can have many movies. This is a many-to-many relationship, and in an SQL database, we capture this with a joining table between the 2 other tables. This joining table will store the primary keys of the records that need to relate to each other. I'll call this table Movie Interest. I'll add the IDs from both tables here with the type of integer, and then add foreign keys for both of them back to their respective tables. Our statement is now ready, so we can run it and see that the table is created. Let's add data to this table. We need to add a row for each interest that applies to this movie, which is all 9 of our records, and they each have a movie ID of 1 because that's the ID of our movie. We can add these with this insert statement here. We run this and the data is inserted. Now that we have the data, let's display it. How would the website show this data? We can see the interests are shown separately and each of them is a link, so perhaps we need a list of each of the interests for the web page to display. This means that we probably need a separate query for interests instead of adding them to the same movie query we have been using. This is okay. We don't always need to get everything in a single query, especially when there are different uses for the data like this. So let's select all of the interests for this movie. We'll need to join to the movie interests table, which is easy to do. We can also filter on the movie ID. Right now, we only have the data for this movie, but once we add more movies, then we'll need to have this filter. Our query is now ready. Let's run it. We can see the results here, which is a list of interests for this movie. This is the kind of query the web page would use. So that's the interests done. Below the interests is a description of the movie. This seems to be a simple text field that could be added to the movie table, so let's do that. We'll write an alter table statement to add this description column. We run this and it is successful. Now we write an update statement so that we can add in this movie's description. We run this and it has been updated. Let's update our main movie query to get this new description field. We run this and see our results here, which include the description field. We're making progress. Just below the description we have the label director, then the name Matt Reeves, who directed this movie. Let's click on Matt Reeves. We can see some kind of profile page. It shows their name, a photo, some titles like producer, writer and director. If we scroll down a little further, we can see a date of birth and a bit of a bio. For this movie, we only see one director. This could indicate that we only need to add a new column for the movie table. However, it seems like the director exists separately from a movie and it has its own page and details about it, like the interests. So we should create another table. We add the name, the roles, bio and date of birth to the table along with the ID. We run this and the table is created. Let's insert some data. We add a row for Matt Reeves into this table. Let's select from this table. We can select each of the columns from this table and see our results here for the director. How do we relate a director to a movie? We saw on our movie page that a movie has one director and a director can work on multiple movies. So this is a one-to-many relationship. To capture this, we update our movie table to add a director ID column and add a foreign key constraint. We store the ID of the director row in this table. Then we add a foreign key constraint to the director table. We can now update the movie record to add the director. Our data is now updated. We can update our movie query to add this director column. We add the director table into our query, add the director name to the select clause and the group by clause, then run our query. We see a new column here for the director name. So our main movie query is growing. How do we see the information on the director's profile page? We can run a select query on the director table. It would look like this. We run this query and see the results here. So this is the kind of query that the application or website could run. The writers are next on the page. We have a few here for this movie. I'll click on this one, Peter Craig. We can see a profile page which looks a lot like the director page. Below the writers we have stars. I can click on a star name and see a profile page as well. We can also see on the movie page that the director, Matt Reeves, is also a writer. What can we do? We could have separate tables for each kind of role involved in a movie, but these tables would all be very similar and are just defined by the roles in the movie. A better way is to store them in a single table and then store and display their role. This would reduce duplicate rows and make it easier to maintain. Let's do that. First, we'll rename the director table to person, as it's storing much more than directors now. We should also rename both the director ID and director name columns to refer to the person instead. Next, we'll add some records for the writers into this table. This movie had 3 writers, but we already have a record for one of them, Matt Reeves. We'll insert the other 2. These rows have been inserted. Let's see what they look like. We can select from the table here and see the results. So we've got our person data added. How can we relate these to movies? As we've learned, a movie can have many of these people, such as directors and writers, and a person can be in many movies. This is a many-to-many relationship, so we'll need to have a joining table. We'll call the table movie person. We'll add the IDs for both the movie and person table, and then create the foreign key constraints. The statement is now ready, so we can run it and the table is created. Let's add some data. We'll insert 3 rows as the movie has 3 people involved. We run this and see 3 people are added. Now that we have added this table, we need to remove the director ID column from the movie table. We can do this with an alter table statement. We can run this and the column is removed. We've captured the people involved in the movie. Here's what the data looks like. We run this query, but we don't see what role each person has. We haven't captured that in our data. How can we store this? We can't store it in the person table because a person's role changes with each movie. We'll have to store it in the movie person table. Let's add a new column for this. I'll call it role name and make it a text value. Now let's update the values. I don't remember which person had which ID, so let's look it up. Here we go. Now which person had which role? We can see Matt Reeves is the director and he is also a writer. So we'll need another record in the movie person table for their other role. The other 2 people are writers. First, we'll update the existing data. We'll set the role of director for this person, then writer for the other 2. We run this and the rows are updated. Let's insert the row for Matt Reeves as a writer as well. We do this and the row is inserted. Now we can update our earlier query to include the role name and run it. We can see the people and their roles. This is good. One thing we may want to do is move this role name into a separate table which has a list of the roles and an ID for each of them. This will improve the data quality and prevent any records with slightly different spellings. What about this stars section here? We can click on a person here, Zoe Kravitz. We see a similar profile page as the writer and director. So it looks like we can use the same person concept as we have for directors and writers and use a role of actor. Let's add some data. First, we need to add these stars into the person table. We can run this insert statement and the data is added. To add these people into the movie person table, we need to know their IDs. We can find the IDs by selecting from the table. We see the IDs here of 4, 5 and 6. Let's insert these as actors into the movie person table. The data is now inserted. We can then run the earlier query to select from a few tables to see more details. We've now got the director, writers and some of the actors stored for this movie. Back on the movie page, we can scroll down to see what else there is. We've got some nominations and awards here and more pictures and videos. If you're building your own movie catalogue, you may not want this, so we'll skip past it. But you could add it if you want. Next we have this top cast section. We've already added some actors to the movie, but there are more than 3 actors in this movie, and this section is where they are listed. One thing to notice here is that it also shows the characters that the actors play, such as Bruce Wayne, Selena Kyle and James Gordon. How can we add this to our database? It's part of a person's role with the movie, so we can add it to the joining table. However, this means that people who aren't actors, such as writers and directors, will have a null value for this column. Is this okay? Maybe it is. If we don't want to do this, we could have a separate joining table. One joining table for movie actors which has the character names that they play, and the existing joining table could be used for non-actor roles. It's up to you which approach you use. For this video, we'll add a new column to the joining table. Once we do this, we'll need to update the existing records. Let's see what they are. We can see our IDs and names here. We want to update the character name for the 3 rows for the actors, the rows with a person ID of 4, 5 and 6. Here's what the update statements would look like. We run these statements and the data is updated. We can adjust our earlier query to add the character name column and run the query. Here are the results. So that's how we can have the characters for our cast. If we want more characters and cast from the movie, we can insert rows into the people table and then into this movie person table. Scrolling down the movie listing page, we can see the director and writers again, then some recommendations for other films. After that, we have the storyline, which is like a short description of the story. We have the taglines, then a few genres here like action and crime. Then we have this motion picture rating and a link to a parent's guide. How can we add this information? The storyline could be a single field on the movie table. The tagline could be the same, a new column in the movie table. What about genres? These seem to be a lot like interests, where a movie can have many and they apply to many movies. So we'll need a table for genre and then a joining table. For the MPA rating, we have already captured the classification. There's more about the rating that we could add, such as why it got the rating, but we won't add it to this design. So we're going to add storyline and tagline to the movie table and the genre tables. First, we'll alter the movie table to add both the storyline and tagline columns. We write these statements, then run them, and the table is updated. Next, we'll update the movie record for Batman to add in the storyline and tagline. We do this and the table is updated. Now we can add the concept of a genre. First, we'll create the genre table. We'll just add an ID and a name for now, but we can expand it if we need to. We run this and the table is created. Next, we can run this insert statement to add the genre records. I've specified the IDs this time so I can easily insert them into the joining table. Then we create our movie genre table, which is the joining table of movie and genre. We can then insert some rows to it, one row for each genre for this movie. Our movie genre and genre tables are now populated. Let's write a select query to get a list of the genres. We can filter this on records where the movie ID is 1, which is our only record, but it's a good habit to get into as we add more data. We can see our list of genres here for this movie. So this data is now added. The next section on the movie page is called Did You Know? It has a range of subsections including trivia, goofs, quotes and crazy credits. Each of these are specific notes about the movie. If we click on one, we can see that item as well as a lot more about the movie. We can add a new table for this concept, where we add the text of what is shown on the screen, as well as a type such as trivia or goofs. We'll call the table Did You Know? I thought about calling it a note, but it felt a bit generic. We'll add an ID, a name, and an ID for the movie. How do we know what type it is? We could add a text value that has the values of trivia or goofs, but I think the better approach is to normalize it. This means we add a separate lookup table of Did You Know type, and then relate this record to the main note record. Let's do that. We'll create this simple table with an ID and a name. Next, we'll insert some rows into it for the different types. Now the data is added, we can relate this to our main Did You Know table. We can add another column into the create table statement here because we haven't yet run this to create the table. We'll also add a foreign key to the type table. We can run this and the table is created. Let's insert some data. We can run this insert statement which adds a range of Did You Know entries into the table. Now the data is added, let's select it to see what it looks like. This query shows the different Did You Know entries as well as their type. This is the kind of query that could be used on this movie page. So this section is done. The next section is the user reviews. This shows one review where a review has a title, the actual review and a rating. If you click on the user reviews heading, we can see a lot more reviews here. They all follow the same concept. Let's add this to the database. We can create a new table called user review. It will have an ID, title, review body and the number given, which is the rating value. This number is similar to the rating, which is between 1 and 10. We could use the rating table we created and add some new columns. It's up to you whether you want to combine these, and there are pros and cons of both approaches. I'll keep it as a separate table for this video. Finally, we add a movie ID. We'll add some constraints, a primary key, a foreign key and a check constraint. We run this and the table is created. We can insert a couple of records into this table. Now let's select from the table. We can select some of the columns and run the query. We can see the rows that we added here. So that's how we can capture user reviews for a movie. We could expand this by adding users who can leave reviews and ratings. I also saw the ability to leave thumbs up and thumbs down on reviews too. There is a lot more we could add to our database. There's a top pick section which is like a recommendation for similar movies. We've got an FAQ section here with some entries. There's a details section that has things like the release date, sites, languages and more. The box office section has information on the budget and revenue of the movie. Most of these sections would follow the same kind of pattern. They may be attributes on the movie table or related tables to the movie. How would you design them and add them to this database? Let me know in the comments below. If you get the project guide for this video, I've added these extra concepts into my database there, so you can see one way of how it could be done. Check out the link in the description. What are some of the queries we may want to run on this table? This query selects some details about the movie. It's the kind of query that may be used to show details on the movie page. It doesn't show everything, as we may need separate queries for the data that can exist more than once for a record, such as interests and genres. We run this and see our results for the movie here. If we start adding more data into the database, we may want to search for specific movies or movies that meet a criteria. How can we find all movies within a certain genre? We can query our genre and movie tables, filtering on the genre name of action, for example. We run this and see our results here. We only have one movie in the database, but with more data, you'll see what you need here. What about all movies that have a rating higher than a value we specify, such as movies rated higher than 7? We can write a query to find the ratings for each movie, then find movies with a rating higher than 7. We run this and see our output here. We can see our movie again here as it meets the criteria, but with more movies we'll see more rows here. Once again, check out the link in the description for the project guide for this video. If you like this in-depth SQL video, you'll want to watch this video next, where I analyse the entire history of basketball games in the NBA to find out some interesting statistics. Thanks for watching.